Hi, I'm Lauren Paulson, and today I want to share with you the charged tape experiment we did in Physics 2. To start this lab, we need tape. We then need to measure out two 8-inch pieces of tape. We then need to fold down the tape so there's a handle and press one of the pieces of tape down to a desk. We then need to press the second piece of tape onto the first piece. We then need to rip these two pieces of tape apart. Now this piece of tape should be charged. As you see, it's attracted to my hand. Now we need to create a second piece of charged tape. When we bring these two pieces of tape together, we can see they repel each other, meaning they have equal charge signs, so either they're both positively charged or they're both negatively charged. We can also see the piece of tape is attracted to a neutrally charged item like the table. This is due to, despite the table being neutral, the molecules in the table will polarize so that the charged tape is attracted to it. Next, we want to figure out the charge on the tape. To do this, we can put it next to an item we know the charge of. We know that if you rub a pen against your hair, the charge of it will be negative. So if the tape is attracted, it will be positive. As we saw earlier, the two pieces of tape repel each other. This force can be enough to even overcome gravity and cause one piece of tape to start to float. These are the physics principles used in this lab and the equations we will use going forward. Momentum on the floating piece of tape remains constant. This means there's a constant velocity and zero acceleration, and therefore also no net force on this piece of tape. Despite there being no net force on the tape, there is still the force of gravity acting on it, as well as an electric force due to the other charged piece of tape. These two forces drawn out look like this. In order to determine the gravitational force on the piece of floating tape, we need to find out the mass. This is because the force is given by F equals ma, and we know A is equal to little g, or 9.8 meters per second squared. So we have to find the mass. The mass can be given by using that fact that the tape is 1 gram per meter and my tape was 20 centimeters long. Using these to calculate it, we get that my tape would have been 0.2 grams. We can also assume that each piece of tape had the same net charge as they were charged in the exact same way. Using this assumption, we can code a glue script model of the tape. We can actually do multiple point charges doing a line of charges. My line, I had 10 points representing this line of charge, and you can see how it repels each other. This gives us a more accurate picture of our lab than just doing this as a single point charge, as our tape in reality would be made up of multiple charges, not a single point charge. When we estimate the charge on the tape as a line rather than a point charge, the charge on the tape is much higher. This would be because the charges are much more dispersed across the tape, therefore having a single lesser pull or push on other charges around it. Another reason why these values differ is because they have different accuracies. A line charge is much more accurate to how it would act in real life than a point charge. Therefore, this newer model is likely to be much closer to the real value of the charge on the tape because it more closely represents the actual process that happens in real life. Thank you so much for watching.